Okay, now let us discuss about that what special thing is being done by an enzyme that the reaction becomes so fast. Like now I have given you the example, with the presence of an enzyme the reaction became 10 million times faster. So what is special thing which is being done by the enzyme? How can the enzyme increase the speed of the reaction? So basically what enzyme used to do, enzyme decreases or lowers the activation energy. Now what do you mean by activation energy? Let me draw a graph first. Suppose here along the y-axis I am having the energy, and along the x-axis I am having the progression of the reaction. Okay, so progression of reaction. Now suppose there is a substrate S. This substrate S has to be converted into the product, and the product is P. And now suppose the reaction is exothermic. Exothermic means the release of heat will be there. Now just think, if the substrate will release the heat, or I can say it will lose the energy, then the energy of the product would be higher or lower? It would be lower. It means the substrate they are having more energy and the product they are having less energy. I am talking about exothermic reaction. Suppose here I am having the substrate. It has to be converted into product at the last, but the energy of the product would be lower. I think you can very well understand. This energy is here and its energy is here. The energy of the product is lesser, as I have taken the example of exothermic reaction. Now you will just think that the reaction should carry out in this way. The substrate will keep on losing the energy and it will change into product. This you will think, but this is not actually happening. Firstly, what happens? This you have done in your chemistry lectures also, that firstly the substrate will change into transitional states, intermediate states that are not stable. That are not stable means they are having more energy. Okay, so this substrate will not directly change into product. Firstly, there will be formation of transitional states that would be unstable. So first of all, it will gain energy by somewhat means, by heat or by anything. It will gain energy. It will make the transitional states that are unstable, and then it will change into product. Like this it is going on. Is it fine? So if I talk about, this was the energy of the substrate. So this much energy, that difference between the energy of the substrate and the energy of the transitional state that is unstable, this difference is activation energy. So basically the substrate will gain the activation energy and then it can change into product. Now what is the enzyme doing? The enzyme lowers the activation energy. Suppose if this reaction is catalyzed by an enzyme. Now what the enzyme will do? It will lower down the activation energy. Now the same substrate is there, but now the activation energy is like this. Is it fine? Now the activation energy is this much. Now just think yourself, attaining this much energy is easier or attaining this much energy is easier? Your answer would be this. So how the enzyme works, how is it able to increase the rate of reaction to such large extent, as it lowers down the activation energy. Clear? Now let us talk about another topic, that is the factors that affect the enzymatic activity. in this we have to study the role of three factors: pH, temperature, concentration of substrate. Okay, now one by one let us discuss what is their effect on the activity of the enzyme. Let us talk about the pH first. Now, enzymes are specific at specific pH. Is it fine? Enzymes are specific at specific pH, and there is a pH known as optimum pH. At this value, the enzymatic activity is maximum. It is different for different enzymes. Like if I give you the example of salivary amylase. Salivary amylase enzyme is present in your saliva. Saliva is in your buccal cavity, you know. So this enzyme works best at 6.8 pH. So 6.8 pH is the optimum pH for salivary amylase enzyme. So enzymes are specific at specific pH. Clear? Now, if there will be 5 pH suppose, then again the salivary amylase will not work that efficient. And if the pH is suppose 8, then again the salivary amylase will not work with that efficiency. So basically optimum pH is the pH where the enzymatic activity is maximum, and below the optimum pH and above the optimum pH, enzymatic activity keeps on decreasing. Let me show you with the help of a graph.